Okay, so this is the drag hinge. I'm going to call this part the rotating arm. I'm going to call this part the fork, and it has two prongs. This is the pin, this is the locking nut, and this is just a small bushing. So the first and main problem is that this the design of this drag hinge is very ineffective. Ineffective in the sense that it doesn't succeed in locking the assembly when the nut is tightened. So I'm just going to put it back together to show you exactly what I mean. Okay, so if we look closely, we can see there is a small, narrow gap between the rotating arm and the fork, right? You can see the light coming through against the white background of this notepad. There we go. And then, yeah, originally I thought, oh, well, that's not a problem because I'll just tighten the nuts and then that will narrow the gap, and then it will pinch the rotating arm and it will lock it nice and tight. However, that's not the case, because if we look again, now it's tight. If we look again, there is still a gap, but only at the bottom. What does this mean? Well, this means that the only place where the prongs of this fork contact the rotating arm are 2 points right here at the top. One up here, sorry about the bad shot, but one up here and one other up here. There's just 2 tiny points there. It's a bit like this. You've got a box, you can have 2 types of contact. You can have flat contact where the whole of the area approaches in this case, this would be the rotating arm, approaches it parallel. So then you've got a flat, nice and wide contact, and that gives you a lot of friction. And then you've got the point contact where instead of going in parallel, the prongs sort of bend inwards like that, and then you've only got 2 points up there, and then what you get is something sloppy like this that's able to rotate pretty much freely regardless of how tight you push against it, because metal is very stiff, very it doesn't deform that much. Certainly not as much as other materials like plastic, for example. And then you get this really there's no friction there, basically. There's no friction because there is very little contact area. Friction is directly proportional to surface area. So now that I have tightened this, pretty tight actually, I can't really go any further. And yet, if we look closely, I'm still able to move this around. And you can see very clearly how it's rotating around here and not around here. I think that's pretty clear from this video. Okay, so that's because we have a single point of contact up there instead of having the whole surface going in flat. So why does that happen? Well, that happens because there is a gap when this thing is relaxed, and second, because even if we bend the metal in, we still have a solid piece of metal down here that this nut is not going to be able to compress it enough to get the 2 sides to go in parallel. So we're always going to end up with with angled surfaces, and you're never going to have that nice and flat, generous contact area. Therefore, we're always going to have low friction, and we're always going to have this play. That's no good. And I want to show you, for contrast, what happens when we switch this part with a plastic one, which I happen to have lying around in my room. This is from one of these Sennheiser dynamic microphone mounts. Very cheap. It's made of plastic. Sorry about that. But it's very effective. It just happens to fit, and in fact, it fits a little bit more snug It's a much better fit. I can't see any light coming through there. It's very nice and tight fitting. That's a good start. But that's not the only reason why it works better. It also works better because it's made of plastic, which is more flexible and it's more compressible. It's easier to deform. So as we tighten this, it is more likely that there will be more contact surface area than with the metal fork. And then right now it's loose, yeah. I haven't tightened it yet, but I'm going to tighten it once I start to feel a bit of resistance. Okay, now I start to feel a bit of tightness there. I'm just going to go through a few more, like a quarter of a turn. That's it. And this is now really, really, I'm going to hold this by where the microphone would be. It's very, very nice and stiff. This is not going anywhere. It's very, very nice and strong. With the metal one, just giving it the quarter of a turn, this is pretty much free to move around like it wasn't tight, like it hadn't been tightened. And you see, the problem with the metal fork is that most of the force that this nut exerts goes into bending the metal. With the plastic one, because it's so easy to bend, most of the force actually goes into creating friction, into pushing, into pinching the rotating arm. So using plastic in this case is actually considerably more effective than using metal. You could argue that, yeah, metal looks more sexy. It's, everybody likes metal. Metal looks like higher quality. Yeah, sure, but plastic gets the job done and metal doesn't work in this case. So this is a very ineffective design. So one possible solution to this problem would be to switch this metal part with a plastic one, and then it would work. Oh, and of course, ideally get the fit a little bit, the clearances a little bit more tight so there is less of a gap, just like this one. And that should be fairly easy to do. An alternative would be to use a one-sided design. So for example, if we only had, let me just see if I can come up with something using something like that, for example. This is made of plastic, of course, it's the Sennheiser one. If we now put this through here, I don't know if this is going to work. It might work actually. Something like that. You see, it's a one-sided fork, if you would. And this works very well. And in this case, this part here could be made of metal, and it is not being flexed in any way because all the force here is being used to create friction. So this works just as well. This is actually quite stiff now. I would say though, if both sides of the assembly were metal, I would probably put a piece of like a nylon washer, or even perhaps a rubber, very thin, but a rubber washer there, a ring, to prevent metal on metal contact. Because as I said, it metal on metal might, it might scratch the paint. It's just, and it doesn't feel as nice. And also rubber creates more friction, so that's a good thing. Plastic would also be probably good, maybe not as good as rubber. I have, in fact, and I'm going to show you, this K&M stand, which here uses 2 rubber discs, and this is very, very long, and it just doesn't move. It's really, really effective. So I think, so we've got metal, rubber, metal. This works brilliantly. So something like that would work as well. Okay, so that is the drag hinge problem. Next, we have, let me get this out of the way. So that was the main problem. Now we've got a slightly lesser problem because this one's really easy to fix, and it's the threaded adapter here. Now the problem with this is, I mean, this is a pretty standard part. I even doubt Lewitt make it themselves. This is probably a Chinese adapter, which is fine. The problem is that this hole is very, very deep. When I put this in here, it just goes in so deep, and then if I tighten it onto a pole or something on the end of the boom stand, it sort of buries itself into the plastic, and it really is extremely difficult to get it back out. The only way to get it back out really is to use a flat screwdriver, but it has to be a very wide one. Now, when this happened to me the other day, and I didn't have one, so I had to go and ask my neighbor to see, and luckily he had one. I wasn't able to get it out. The problem here is that these adapters are designed to be twisted, turned using a coin, because most people have a coin lying around. You just put the coin in here and then you turn it and then it works. But you can't get the coin into the hole. So my suggestion here would be to use something like this adapter, which has a flange, and the flange stops it from going into the hole. This one's made of plastic, it's very crappy, but you can find metal ones as well. And that would work, and that is just it's a really easy fix. So I'm sure Lewitt could perhaps deliver this product with this sort of adapter. What else? Oh yeah, the pouch. So this is the Lewitt pouch. You can see here, I've turned it inside out just to show you the problem. The seam, look at that. It looks very rough. It looks really like unfinished work. You see all these bits of fluff flying around, and then the feel of that is very coarse, very rough. It doesn't look like it's going to protect the microphone. In fact, it might actually scratch it. And I want to show you, for contrast, this Sennheiser pouch, which, may I say, overall feels like it's a lower quality product because it's very light. The materials feel very, it's very crinkly, feels cheap, but the finish is very luxurious. Look at that. It's got this strip here that conceals the seam, and it just looks very, very, very elegant. And that will protect the microphone better because it's got a nice feel to it. So Lewitt could do the same on the pouches. I think that's probably everything. Oh, one more thing about the pin. The pin, where is it? Just remembered, sorry about that. Yeah, it would be probably a good idea to reduce the amount of play there as well, because this is it sort of compounds, it adds to the problem. This is very loose. I guess this is probably not so important, but perhaps it would be nice if the diameter of that hole was a little bit smaller, certainly, to reduce the amount of play on that pen. Yeah, that's all the things I wanted to say. So thanks for watching, and I look forward to your comments. Bye.